Hello everyone, welcome back to mahafarkar.co.in. In today's video, we are going to deal with one of the important terms related to viscosity. If you remember, we have learned the viscosity and the types of flow. There are two types of flow, streamline flow and turbulent flow. The flow of liquid in which all the layers of liquid moves with constant velocity. Velocity of first layer is V1, it will remain V1 till its end of the flow. Velocity of second layer is suppose V2, then it will remain V2 till end point of the flow. In such type of flow, we are going to call the streamline flow. Whereas if the velocities of liquid are not remain constant throughout, then we call it as what? Turbulent flow. The ability of liquid in which different layers of liquid exerts the force because of which the relative motion of liquid layers is get opposed, we call it is what? Viscosity. So if you remember, we have learned about viscosity also. What is viscosity? It is nothing but what? In short, friction in a liquid. So how it acts? Then it produces what? Opposition to motion between relative layers of liquid. Relative layers of liquid get opposed by each other, get opposed, due to which the property is called as what? Viscosity. The viscosity can be studied on the basis of viscous force and the velocity gradient. We know that for given streamline flow, the ratio of change in the velocity, ratio of what? Change in the velocity. So if this is the first layer whose velocity is v, layer above it will have little more velocity, whereas layer below it will have little less velocity, and the distance of that layer from the ground or bottom will be different. So ratio of change in velocity per unit what? Change in the distance. This ratio we are going to call as what? Velocity gradient. So what we are going to learn in this article now? We are going to learn about two important terms. First is the formula for viscous force and second is the coefficient of viscosity. So let's start. The actual article for today's video is, that is, the coefficient of viscosity. Coefficient of what? Viscosity, indicated by eta. This was studied by Sir Newton, and Newton studied streamline flow of any fluid. Streamline flow of fluid. Now what he observed? He observed that if the area of the fluid is more will be the number of molecules. More is the number of molecule, more will be the collision, more will be the opposition. So he studied few things and concluded important terms, and that terms will use as the Newton's law of viscosity. So it will nothing but as what? Newton's law of viscosity. So what he suggested, Newton, and remember this is strictly valid for which flow only? Streamline flow. So what Newton said? According to Newton, viscous force acting between layers of liquid or fluid is, first point what he observed is directly proportional to the area of layer. Now remember here, area of layer doesn't mean the area of the container or the exact entire flow. It is the area in which the interaction is considered to be happening. Okay. So more is the area, more is the viscous force according to the Newton. Secondly, he said that it is again directly proportional to, it is what? Again directly proportional to the magnitude of velocity gradient. It is directly proportional to what? Velocity gradient, that is dv upon dx. Newton observed the streamline flow and he concluded these two things. In the first thing, he said that the viscous force acting between different layers of fluid or liquid directly proportional to the area of layer. Why he suggested why he must have suggested like that? Logic is very simple. Area is more, number of molecules are more, as I said previously. So when 10 molecules are there and they are opposed by 10 molecules, then we can consider resultant force is 0. But when area is increased, 100 molecules are opposed by 10 molecules, then there will be the more effective resistance, and that resistance here will be nothing but what? Viscosity. So if I write these things mathematically, then what we will get? Viscous force F directly proportional to area and directly proportional to velocity gradient, that is dv upon dx. So here constant of proportionality will be there. So eta is the constant of proportionality here. So we can get the equation F equal to eta into A dv upon dx, where eta is constant of proportionality, and this constant of proportionality here is called as what? Coefficient of viscosity. It is called as what? Coefficient of viscosity. Okay. So from this equation you can get the value of eta. What should be the value? See here. So from this eta can be equal to, this entire thing will be go in a denominator towards LHS, so it will be A into dv by dx. So from this formula you can easily define the definition for eta, that is viscous force acting per unit area per unit velocity gradient. Viscous force acting per unit area per unit what? Velocity gradient is called as what? Coefficient of viscosity. So what should be the SI unit for this? Let's find SI unit. See, it is force, so Newton divided by area, that is meter square, into meter per second upon meter. No, it will be like velocity upon. So if you remember, we have already found out the unit. It is what? Per second. Okay. Velocity gradient has unit what? Per second. So this second should be shifted to the numerator. It is Newton second per meter square is SI unit, and CGS unit is dyne second per centimeter square. If you convert dyne centimeter square into this one, then you will get, see, if I convert Newton into dyne, so 10 raised to 5 dyne into second divided by meter square means 10 raised to 4 centimeter square equal to dyne second per centimeter square. So see how much it will remain. 1, that is 10 dyne second per centimeter square is equals to 1 Newton second per meter square. This unit is also called as poise. So 10 poise is equals to 1 Newton second per meter square. That we have to remember. Okay, this was the formula for coefficient of viscosity. Now we are going to learn another term to study the viscous force acting on the spherical body when it falls in the viscous fluid. Now that was studied by Sir Stokes, and hence that statement itself is called as what? Stokes' law. So let's learn it simultaneously. Imagine that there is a viscous fluid, like say uniform layers of liquid air are there, and one metal ball is falling. Metal ball is falling here. So the corresponding layers which are close to that metal ball will be get opposed like this. Okay. So this force by which the metal ball is get opposed, this metal ball is going to get opposed by the corresponding layers will be depend upon certain factor, and that factor was studied by Stokes' law. So what is the Stokes' law? If a spherical object is falling freely in viscous fluid. It is strictly spherical object falling freely in a viscous fluid, then the viscous force is directly proportional to, viscous force acting on the object is directly proportional to, see, first factor what he said is the radius of the object. See, more is the radius, more will be the surface area which is in contact with the given surface, and therefore more will be the opposition by that object. So radius of the object. Second is that force is directly proportional to the velocity of the object, velocity v of the object. More the velocity, more the downward force. To balance that, more the upward force is going to be exerted by that substance. And third is the coefficient of viscosity of fluid. Coefficient of what? Viscosity of fluid. These both are for that body, spherical body, and that coefficient of viscosity for fluid is eta. So if I combine these three, then according to Stoke's law, I can say force is directly proportional to radius, force is directly proportional to, say radius is capital R, directly proportional to velocity, and force is directly proportional to eta. So therefore I can say F directly proportional to R V eta. F is equals to K into R V eta. Using some derivations, some practical calculations, the value of K was found by Stokes as 6 pi, and therefore we get formula 6 pi R V eta as the formula of viscous force acting on what? Spherical body. You can verify this using dimensions. What you are going to do is substitute dimension of all the quantities on LHS and RHS, compare the powers, and then you can get the correct formula which is given by Stoke. So this was today's article. I hope you understood this one. Thanks for watching mahasarkar.co.in. Thank you.